Okay, one film. Hello? Oh, hold on a minute. There we go. Greetings, viewers, and today, after a way too long wait, we have our Thought Films Episode 3. Well, Series 1, Episode 3. Trust me, I've got a lot planned. But hopefully, for the next 7 episodes after this, we can make them a bit of a regular thing. And then maybe I'll definitely make a playlist. I might even create a new channel just for this, but I don't think I'm at the stage of having 2 different channels yet. Anyway, let's get started. So, in the first one we covered some of the theories, the second episode looked at impossible colours. Today, I'm going to discuss binary code. Well, binary code is a language, as you may know. It's a computer language. Now, I'm just going to have a look in my little notebook at some of the things I put down. So, binary code is it always looks like a series of 1s and 0s. That's what it is. It's used a lot for things like computers and programming electrical circuits. You know the whole on-off thing, true or false. It's got a huge part in shaping the lives of everyone today because of its impact, but I'm talking more about the cool stuff to use it for here. Oh, you know what, you'll see. Anyway, you can represent it on your hand though, because we were learning this in maths way back. That's pretty much what I'm teaching you. So, take, let's say this hand, yeah? Now I want you to imagine for me, each finger represents a number. So you've got 1 here, 2, 4, 8, and 16. Now you can create any number with this, pretty much, up to, with them all added up, which would be about 31, I think. So look, that's 1, that's 2, that's 3, and so on and so forth. But you could do a lot of interesting gestures. Like a thumbs up would represent, well, in this case, it would represent 16. This piece up sign would be 12 because it's the 4 added to the 8. However, binary actually comes in strings of 8 numbers always, so really, it's not this. In fact, it goes from right to left as well, which is also confusing. So, for it to be accurate, I'm going to flip it around so it makes more sense to you. With this on the right. 1, 2, 4, 8, 16, 32, 64, 128. So you've got 8 possible spaces there, and each one can be a 1 or a 0, on or off. So on would represent being up, and off would represent being down. So, say I did this. We have a 1, we have 8, 16, 32 and 64. So what number would that represent? Now this is all good and well, but how would you actually speak binary code? Well, there's another chapter in here which I shall sort of partly cover. If you want me to look at it in more detail another time, please let me know down in the comments below. Numbers and letters have equivalents because thinking about it, if A is 1, B is 2 and Z is 26, so on and so forth, you can get them to represent each other. And I've got a chapter here about number equivalents, such as how to turn your name into a set of numbers, a string of numbers, and like a code. It's very good, but it's also quite simple really. It's a classic code there. To make it complicated, you need to like, get a Caesar shift or something. But anyway, back to binary. That's good, but what if we could make pictures with binary code? If you've got this on and off thing, what would that mean? Because pictures, how would you create a picture? Well, think about how computers do it. We've got lots of pixels. For simplicity, let's just stick to black and white now, because we've only got on and off. Say you've got a grid. Now, you're trying to translate a picture. So on could represent black and off could represent white, a 0 and a 1, or vice versa. I don't know how I've really written it in here. Yeah, white is off, black is on. So this image, you've turned it into a string of numbers, because if you start from the top left and just work as you normally would, or in this case, since it's binary, from top right and down, that would become string of numbers, with each box has its own digit. Here's an example. Alright, this is where the fun starts, so listen up. What if we had colour? How would we do that? Just think about this for a minute. I want to see if you can work it out. If you were in my maths class, then you might already know this. So, black is on and white is off, 0. So we've got 1 and 0. How do we add colours? Like, say if you want to have red, so black, white and red, like the albino comics, or yellow, maybe blue, green, purple, indigo, brown, I don't know. The way you would do it, if you haven't worked it out already, which I'm giving the chance for you to do so now, whatever. Add more numbers. That's simple. So you've got 0 is white, 1 is black, then you can have 2, which means red, 3, which means blue, and 4, which means green. That would be interesting, wouldn't it? So you could have coloured images, and when you get this string of numbers, it's just, instead of just 1s and 0s, it's got 1s, 2s and 3s. Now that's not really binary code, but it's still a code. It still works. Coding is a lot of fun, I think. And remember, this string of numbers won't necessarily be in the dimensions of the image, which is why you've got to count it up and find 2 prime numbers it divides by. If you're using this as a code with your friends, you'll probably have a system already, so you'll know, like, the image will always have these proportions and have the x-axis before the y, or maybe you will arrange it in that way. But moving on, here is an example I made. So I was bored, I was playing Star Wars Knights of the Old Republic, so I made this guy. He's holding 2 lightsabers and the background's just sort of alternating colours. Anyway, point is the code beneath. I don't know how you guys can see that, but maybe I'll leave a snapshot on. Now I'll explain it here. So you can see the 1s and the 0s, but you can also see the 2s, the 3s and the 4s. Because over here, I've got where I've actually represented those same numbers. So the numbers mean the colours, so on and so forth. So yeah, ooh, that's enough, isn't it? Or is it? What about real life uses? SETI, S-E-T-I, the search for extraterrestrial intelligence, is an organisation, I guess? Yeah. They, clues in the name, are searching for extraterrestrial life. Now what they have this amazing technology where they can beam out radio waves into deep space, because of course radio waves, the one kind of waves which don't require particles to travel, so they can go through a vacuum. Again, if you want a video on this kind of thing, in the comments. So, SETI send out these radio waves at different stars and other objects in space. And what basically happens, I don't quite understand it myself. So, I mean, I do a bit, but I couldn't explain it. These waves bounce back, and from the way the waves come back, the scientists can use computers to turn it into a string of numbers. Maybe there's something different about, you know, each wave, like the size and shape of it or something. And that creates binary code because it's all ones and zeros. And in the same way I've just shown you, they can make pictures from this. And using that, they can try to determine if there's like the waves that are coming back are just natural things like solar flares or whatever, or if they're actually alien radio waves created by technology and they're broadcasting a certain picture. Because that's basically what the scientists are doing as well. So, yeah, that's all good. If you're interested, I'm going to put a link in the description for SETI's website, because I think they are quite an interesting bunch. And I think that's all for today, folks. So, thanks for watching. Also, remember, please send me lots and lots of questions for the Q&A as mentioned in the previous video, because at the moment I have no questions, and if I don't get 30 or so in the next 2 weeks, then I'm gonna have to call it off. Oh, and there is one other thing. At the moment, I want to do more of these videos because I've got so much information compared to everything else. So, should I make the Thought Films a regular fortnightly occurrence, like Thought Films, something else, or shall I just stick with the vlogs coming every other video? Again, it's up to you. I try and talk to the audience like this because I think it makes you guys a little bit more involved, so you can get your own word in about what you want to see on this channel. As always, remember to share, like, comment, and subscribe! Hashtag, can we make it to 50? Yeah. We're done.